throw it up in the air, most of the time it comes back down, right? You throw a ball, you've seen it happen before? Look it up on YouTube if you haven't, okay? The motion, the height of that ball as a function of the time is quadratic, okay? Acceleration due to gravity and all this stuff. And what you find in most cases is the height of a ball can be modeled by that equation. Okay? This negative 16t squared, this has to do with acceleration due to gravity. This v sub 0, this is the initial velocity. Okay? And that's either the equation will be given or that number will be given. And h sub 0 is the initial height. Okay? So maybe I'm standing on top of a building throwing up a tennis ball or something. Or maybe I'm like holding it on the ground and throwing it up. Wherever I am, the place from which I'm throwing up this ball or whatever, dart, I don't know, lawn dart, that'll work. That's my initial height. Okay? And these are just numbers that you plug in there and there. Okay? So the problem I want to work goes like this. And I've got only a few minutes, so I'm going to cut out a lot of words. Suppose I give you that the height of some object is modeled by negative 16t squared plus 64t plus 160. Okay? So this is some object that I'm throwing up at 64 feet per second. Okay? Maybe I'm throwing a baseball kind of fast. And that 160 right there, I'm on top of some building 160 feet up in the air. Okay? And I'm throwing this baseball up. Okay? The first question I want to know is, what is the height after 3 seconds? Okay? If I'm giving you the height function as a function of time, then what I'm really asking you for here, I just want to know what's h of 3, right? Take 3 and plug it in for the time. This is something that we did back in 2.3, right? That's a skill you already know how to do. You can just plug in 3. I don't care what that answer is anymore. Moving on. Next question. h of 3 equals blah, blah, blah. Okay. Next question. When is this object going to hit the ground? If I give you a height function, when it hits the ground, what are we looking for? What's the height of it on the ground? 0. That's when does h equal 0. So we plug in 0 for the height. And do you know how to work that problem? Sure. This is just solving a quadratic equation, isn't it? This is like a 1.4, 1.5 kind of problem. Even if I said not just the height, when does it hit the ground, but like when is the height 10 feet? Then you're still just plugging in 10 for the height, and it's still a quadratic equation that you got to get in the standard form first, right? Okay. So the meat, the part of this problem that really comes out of 3.1. When does a ball reach a maximum height? And what is the maximum height? Don't look at your class. Okay? Here's the idea. Because we don't have time to work it out. It turns out, when I look at this thing as a function of time, that's t, that's h. Just on the picture, if this is the height of the curve over time, the maximum height is right there, right? What am I really, really asking you for when I say when does it reach a max height and what is the max height? I'm asking you for the vertex. So you would, by whatever method you choose, find the vertex of that curve. Is that reasonable? I mean, is the idea simple enough? Whether, I mean, actually finding it's going to be some work. But that's the idea? Okay.